Viewers beware. This is not an introduction to how spherical coordinates come to be. This is just a practice of a conversion from the world of X, Y, and Z to the world of spherical. And on our way, we're going to use cylindrical coordinates as well. For those that want the practice, enjoy. So this example, we're going to look at the point X, Y, and Z, -3, 0, 0, and we're going to convert to cylindrical coordinates. So I always tell my students it is extremely important to have kind of more than one view, since we don't have three-dimensional graph paper. So the top view is where I begin. So this would be looking down upon the X and Y axis. And if Z-axis were drawn, it would come straight out the screen if you had your awesome, amazing three-dimensional, VR goggles on. So top view, so X is -3, Y is 0, and Z is also 0, so that point would be here on the X-axis. This tells us a lot. It tells us that in cylindrical coordinates that the distance from the origin in the XY plane is 3. It also tells us what theta is. Without too much work, theta is pi radians, or 180 degrees. And then the Z does not change at all. Z is still 0. So our cylindrical coordinates are theta Z would be 3, pi, 0. Whereas I tell my students cylindrical coordinates is polar plus Z. Now spherical coordinates use a bit of the same information. The theta is going to stay the same. So we're going to have our theta equals pi. Oh, that's not the look I was expecting there. Theta equals pi, just like you were in a classroom. Forget this editing the video to make it perfect. Let's do it real. So that's not going to change. And then what I tell my students is the best thing you can do to help yourself, since we're now needing to view this as a third dimension, is to think of this now as a side view in space, and let this maybe be the x-axis, and then this is the z-axis, and the y-axis would be coming directly out at us. So it's kind of like our eyes are at ground level looking across the horizon, and you can see z going up into the sky. If your imagination can get that out of my pictures, then you are quite amazing. But it just so happens that this point is still 3 units to the left on the x-axis, and that's enough to tell us that the distance from the origin is still 3. In 3 dimensions, that distance is the letter rho, which when I write it looks an awful lot like the letter P, but this is the letter rho in the Greek alphabet. Now, the angle phi, sometimes it's drawn more with a vertical line here, is measured from the positive z-axis, and so from here down to here, phi is going to be exactly pi over 2 in this particular diagram. Again, drawing it in space, not particularly easy on a flat piece of paper, but this is what I would tell my students is a good time to do sort of an arm graph where you pretend you're the z-axis and let your arms be x and y so that you can better visualize these. Anyway, when the dust settles, our spherical coordinates for this point, the spherical coordinates are going to be the radius from the origin is 3, and theta does not change as pi, and phi or phi is pi over 2. There you go. I'll attempt to put a link in the description for this video that takes you to a little applet where you can kind of mess around with changing spherical coordinates and see what the point looks like. it's a little bit better than my drawings for certain. Good luck!